Partial fractions are the fractions that are formed when a complicated looking algebraic fraction is split into two or more simpler looking fractions. It's like working backwards when you add algebraic fractions. We're working out what were the original fractions that were added together to get the answer. Example 1, this is the easiest type of partial fractions question, and this is when you have two or more linear factors in the denominator. So our linear factors here are the x plus 2 and the x plus 3. So we can start by saying we know that x plus 5 over x plus 2 brackets x plus 3 can be written as a over x plus 2 plus b over x plus 3. So those two things are equal. Now, when we add fractions, we want to make sure that we have a common denominator. In this case, the common denominator is going to be x plus 2, x plus 3. We change the numerators accordingly, and this shows us that if we were to add these two fractions together to get one fraction, we would get this. Now we can ignore the denominators because we know that they're the same on both sides, and we can just set the numerators to be equal to each other. X plus 5 equals a brackets x plus 3 plus b brackets x plus 2. Now all of this working out is actually not needed. You can shortcut straight to the line that says x plus 5 is equal to a brackets x plus 3 plus b brackets x plus 2. I just showed you that working out so you could see where it came from. This is what you need to write down. And now we know this, we can actually work out a and b. There's a couple of different ways of doing that, but I'm going to show you something called the substitution method, which involves setting x to be equal to different things to find a and b. First of all, we could let x be equal to -3. Now that's a smart choice because if you do that, this bracket becomes 0 and therefore a disappears and you're left with 2 on the left-hand side because -3 plus 5 is 2, and then minus b on the right-hand side. So that tells you that b is -2. Now, if we think about how to make the other bracket equal to 0, that would be if x was -2. If we sub that in, we actually get a is 3 straight away. Therefore, the final answer is that x plus 5 over x plus 2, x plus 3 can actually be written as 3 over x plus 2 minus 2 over x plus 3. And that's it for the partial fractions. Example 2, we've got repeated factors in the denominator. The repeated factor here is the x minus 3. When we have repeated factors in the denominator, we need to lay out the partial fractions in a particular way. We need to have a over x minus 1, which deals with this factor. And then for the repeated factor, you need one fraction that's got the bracket on its own, and then one fraction that has the bracket squared. Other than that, it's very similar to example 1, and we'll use the substitution method again. So let's start by setting this equal to this. And then if we think about what the numerators would look like, if we were to add all of these fractions together, it would be 5x minus 13 on that side. And then on this side, we would have a times x minus 3 squared plus b times x minus 1 times x minus 3 plus c times x minus 1. Now we can do the substitution method to find a, b, and c. Let's start with making this bracket equal to 0. And to do that, we need x to be 3. We get 2 equals 2c, therefore c is 1. Now we make this bracket equal to 0, and to do that, let's say x is 1, and therefore we get minus a equals 4a, and so a is -2. Now we know c is 1 and a is -2, we can substitute those values in here. We can choose a third x value to substitute in, and you can choose whatever you like, but I usually choose 0 because 0 generally makes the numbers nicer to work with. On the left-hand side, we'll have minus 13, and on the right-hand side, if we substitute everything in that we know, it's going to look like a times minus 3 squared plus b times minus 1 times minus 3 plus c times minus 1, and then we can sub in the a and the c to get this, and you end up with b equals 2. So we found the third letter. Now all together, that means we've got this, and we're finished. The last example involves an improper algebraic fraction. This is one where the numerator degree is greater than or equal to the denominator degree. For these ones, you need to do algebraic long division first. I've made another video on algebraic long division, so I'd recommend you watch that one as well if you haven't already. So for this particular question, the degree of the numerator is 3 because it's x cubed, and the degree of the denominator is 2 because it's x squared. If we expand the denominator, we get x squared plus 2x plus x plus 2, or x squared plus 3x plus 2. And we need to do that because we need to do the algebraic long division now. We need to take the numerator, 2x cubed plus 7x squared plus 8x plus 2, and divide it by the denominator. When you do that, you get this. So we have 2x plus 1 up here and x as the remainder. Now the 2x plus 1 is actually the ax plus b in this format. And then the remainder is what we're going to split into partial fractions. So we've got 2x cubed plus 7x squared plus 8x plus 2 over this equals 2x plus 1 plus, for now, just the remainder, so x over x plus 1, x plus 2. This is from the top of the division, and then this is what we're now going to split into partial fractions. So let's go ahead and do that. We've got x over x plus 1, x plus 2 equals, and then let's use the letters from the question, so c over x plus 1 plus d over x plus 2. If we set the numerators equal to each other, it's going to look like this. And then we can do the substitution method again. So make that 0 by setting x equal to -2, and we get this. Make this 0 by setting x equal to -1, and we get this. And therefore, final answer is, altogether, this fraction equals this. That's it for now. If you found this video useful, please do remember to like, comment, and subscribe to my channel if you haven't already. And do share this with anyone else you think might find it helpful. Thanks, and see you next time.